Hey math kids, today we're going to take a break from completing the square and instead we're going to learn how to factor quadratics. So let's start with this. Now factoring is nice because most of the time it takes less time and effort than doing the other methods like completing the square, and you can eventually use it to do the same things. We won't take it to the same places we took it. I'm only going to focus on two factoring methods. So this first one is, we need to have something in the form x squared plus bx plus c. To try it, sometimes it still won't work, but the important thing is that our a is equal to 1. So there's nothing in front of the x squared. Now if we have that criteria, what we do is we put a t under the 10, or the c term right here, and we write down all the ways that we can multiply to make that number. So it's just 1 times 10 and 2 times 5. Sometimes we'll have much more factors, but what we want to do is choose the ones that can be added or subtracted to make our b term. So in this case, if we put a negative on the 5, negative 5 plus 2 would give us a negative 3. We also want to check that negative 5 times 2 is negative 10. So sometimes you'll have two factors that appear to work, but only one of them will multiply together to give you what you started with. So once we have that though, all we do is say x plus the first factor, x plus the second factor, and that's our answer. Okay, so let's try another one. This one, once again, this is called t factoring. And it's named after the fact that we use a t right here. Okay, so let's try another one. Let's do x squared minus x minus 12. So it fits the form that we need, written in yellow right here. There's no a in front, or like the a is 1. So then we just do a t. So we have 1 and 12, 2 and 6, 3 and 4. We want to make the number that's right here, so that would be a negative 1. And so to do that, we need to do 3 and negative 4. We multiply those together, and it does equal negative 12. So now we just need to write our answer, x plus 3, x minus 4. Okay, so that's pretty much it for t factoring. Now, we're going to move on to the case where, what if you have something for your a? So ax squared plus bx plus c. Sometimes I call it modified t factoring or box method. So I'm just going to call it box method. And it's named after the fact that we use a box that looks like this. Okay. So I'm going to do 3x squared minus x minus 2. We kind of start the same way as t factoring. So I'm going to take the 3 and multiply it by the negative 2 and get negative 6 out here. And then I'm going to t factor that. Now, just like in t factoring, we want to find the factors that add up to this term. So if I create a negative 3 right there, negative 3 plus 2 equals negative 1, and then negative 3 times 2 does equal negative 6, and so that works out. Now here's where it deviates though. Now we're going to draw a box that kind of looks like a window, I guess. And what we're going to do is we're going to take the first term, so that's all of that, and put it in this box. Then we'll take the last term, or the constant, and put it in this box. Then this is the part that kind of trips up kids conceptually. But what we're going to do is we're going to split this negative x into 2 different terms. And that's what we're going to put in the 2 remaining boxes. Now, the way we choose to split that up is going to be 2x and negative 3x. So it's based on these factors that we decided worked out for us. So if we took negative 3x and we added it to 2x, we would get back to negative x. So once again, we just split that into two common terms in a very specific way. Okay, now what we're going to do is we're going to factor out based on rows and then factor out based on columns. So we look at these two terms, and we have a 3 and a 3, so we can take out a 3. Then we have an x squared and an x, so an x is all we can take out. We have 1x here, 2x is here, so we take out 1. Down here we have a 2 and a 2, so we take out a 2. This way we can only take out a 1x, and then this way we take out a negative 1. The reason why I chose to take out a negative is because they're both negative. Now, this is just a hypothesis for our final answer. So what we need to do to check to see that our signs are right, we're going to say 3x times x, which gives us 3x squared, so that worked. 3x times negative 1 is negative 3x, so that works. 2 times x is 2x, and 2 times negative 1 is negative 2. It's important that all those signs work out. If they do, we just write our final answer. So 3x plus 2 times by x minus 1. Okay, let's try that one more time with this problem. So now we have y equals 5x squared plus 9x minus 2. Once again, we multiply the a and the c term, and we get negative 10. We get 1 and 10, 2 and 5. We want to choose the ones that add up to 9. And to do that, we would need a negative 1. 10 times negative 1 does equal negative 10, so that's a good choice. It helps maybe circle these so you don't forget about them. Okay, we're going to bring down the first and the last term. So the first term goes here, last term goes here. Once again, we are splitting this 9 into two terms. So we're going to split it based on these factors. So negative x and 10x. If we did 10x minus x, that would end us up at 9x. And we just put it in here. Now it doesn't matter, the green numbers, it doesn't matter which one's which. If I put the 10x down here and the negative x up here, it would work out the same way. Okay, we're going to factor out of this row. 5x squared, 10x, what they have in common, they're both divisible by 5. This has 2 x's, this has 1x, so we'll take out an x. This, they only have a negative 1 in common. Once again, they're both negative, so that's why I chose to take out a negative. Going this way, we can only take out an x. Then going this way, 10 and 2 are both divisible by 2. So that's our hypothesis for the answer. We got to check the multiplication. 5x times x is 5x squared. 5x times 2 is 10x. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. I'm satisfied with that. So I write 5x minus 1 times x plus 2. So that would be my final factored answer. If you, let's see. I guess there's more to this assignment. So let's keep talking. I was going to end the video. But this one we want to determine where these are undefined. And let's see. Let's do x squared minus 3x minus 10. Okay, so conceptually, what we're going to worry about on this one is where the bottom is equal to 0. So division by 0 makes things undefined. It's asking the question, determine where the following functions are undefined. So we actually only care about the bottom. The top doesn't matter at all. So I'm going to just rewrite the bottom. And it looks like one that we can t-factor. So I'm going to t-factor. In fact, we actually already did this earlier in the video. I put a negative here so it can add up to this. So I get x plus 2 and x minus 5. Now we want to know which x values make it equal to 0, so that's why I set this equal to 0. And so what we're going to do is we're going to take just this piece, set it equal to 0, and then set this piece equal to 0. It's actually called the zero product property, and it's the idea that if we have x times y equals 0, we know that at either x equals 0, or y equals 0, or both equals 0. So we're going to just try out each case. So we're going to say x plus 2 equals 0, and x minus 5 equals 0. So we subtract 2, and x equals negative 2. And then we add 5, and x equals 5. Okay, so those are the two places. If we were to plug in 5 for all these x's and simplify, this would equal 0. If we were to plug in negative 2 for all these x's and then simplify, it would equal 0. Once again, the top doesn't matter. We're only setting the bottom equal to 0. Okay, let's try one more of those. Okay, once again, the top does not matter when we're talking about whether or not something is undefined. So we set the bottom equal to 0. We do our t factoring, 1 times 2. We're trying to add up to 1. And so to do that, we get, we want a positive 1, so it's 2 minus 1. Multiply these together, they still equal negative 2, so that's good. X minus 1, x plus 2. That works out. Set it equal to 0. Set each one individually equal to 0. Solve for x. And those are the two values where this purple thing would be equal to 0. If we plugged in a 1 for all of the x's and simplified, the bottom would be 0. If we plugged in a negative 2 for all the x's and then simplified, the bottom would be 0. So that's the two spots where it's undefined. And the final type of problem that's on this is a story problem.